Here's another way. I actually don't recall offhand if Priest introduces this way, but it still can be useful. It was dimming there. This is a conditional, so this is the same formula we were just talking about. It is a tautology, we've demonstrated it to be. Think about the English way that I reasoned through that. I said, well, imagine that if A and B, then here's why this has got to be true. For conditionals, a legitimate mode of proof is to assume the antecedent and get to the consequent. If the only thing you assume is the antecedent, and that by itself is enough to make the consequent true, then this conditional will be true whatever else is true. It will be true unconditionally, independent of the conditions in the world, meaning it's true always, thus it is a tautology. So this works for conditionals. It will thus work for one other kind of formula in PL and in every other logic that we're going to encounter. If you remember what conditionals are, that will tell you what that other kind of formula is for which the conditional proof would work. In a modified form, I will say. But let's concentrate on what we have at hand. So we set it up. How do we set it up? I just assume the antecedent. It's A and B. Cool. That actually makes something like a legitimate mock-up of an and. Okay. We got A and B. Remember what I said. By De Morgan's, this turns out to be B or not C. And if this tells us B is true, and guess what else is true? B or whatever. So long as, again, hopefully you're sick of me saying this, so long as you interpret the V, the or, as our logic does, which just means at least one. Could be both. So at least one of B or not C. Okay. Didn't exactly center that, but we'll just roll with it. We're not quite done, because we have to run De Morgan's on this. And remember, De Morgan's can pack in negations, but it can also generate the packed up form by reversing the procedure. So I add a negation, I change the negation status of both sides. B was unnegated, so it becomes negated. C was negated, so it becomes unnegated. I flip the sign from or to and this whole thing is knotted. Simple. If you can find a non-reductio way to prove things, it tends to be shorter. Tends to be. That's not a universal law. But whenever we're talking about demonstrating entailment, if you're told that the entailment holds or not, then you can absolutely know that you can go forward and prove that by the reductio strategy. These require a little more creativity, but once you get used to it, you see it, and I think it's a little more fun than just grinding out reductios, but there you are.